So in this video, we were gonna focus on identifying the local maxima or minima of the functions. So we have a generic shape of a function like this one. So this point is the local maximum and this point is the local minimum. So we have a tangent line of the maximum and the minimum. So in the tangent line, so we have it is equal to function of the first derivative is equals to 0. So for example, we have a function of, so example number 1, we have a function of f(x) is equals to x squared minus 4x. So the first step in finding the maxima or the minima is we're going to find the first derivative. So the first derivative is 2x minus 4. So we have the 2x minus 4. And the first we're going to base on this equation. So we need to equate the first derivative to 0 to get the local maxima or minima. So 2x minus 4 equals 0. So 2x is equals to 4 over 2. So x is equals to. So this one is called the critical number. So now we have the critical number. So we're going to substitute this one into our main function. So let's have the f2 equals 2 raised to 2 minus 4 times 2. So we have 4 minus 8. So we have f2 to negative 4. So we have a ordered pair of a maxima or minima. We have a ordered pair equals. To find out if this is a maxima or minima, so we need to get the second derivative. So if the second derivative is equal to or less than 0, is less than to 0, we have the maximum. So if the second derivative is greater than or less or equal to 0, so we have the minimum. So I repeat, to find out if this is a maximum or a minimum value, so we need to get the second derivative. So if the second derivative is less than 0, so we have the maximum. So if the second derivative is greater than 0, we have the minimum. So let's find the second derivative of the function. So the second derivative of the function is equal to, so we have the first derivative, so we only get the second derivative of this one. The second derivative of this one is 2, only 2. So only 2. So we have 2. So we have 2. So the answer is the positive. So this is a minimum value, because the answer is greater than 0. So that is the first example. So we have a second example. So to find the first derivative first, so we have 6x squared plus 6x minus 12. So we're going to factor out 6. So we have a simplification form. So we have x squared plus x minus 2. So this one we're gonna equate into 0 to find the critical values. So we have this one. So and we're going also factor this form because this is a quadratic function. So this is will be 6x. So x, we're gonna use plus 2 because this is a positive. X minus 1 equals 0. So we have this one. So we have a functions of, we have a critical numbers of x plus 2 equals 0 and x minus 1 equals 0. So we have x equals negative 2 and x plus 1 equal x equals 1. That is our critical numbers. So then we're going to substitute this one to our main function. So we have negative 2 equals 2 times negative 2 so we calculate this one. So if you calculate this one, we're going to have a 20. And the if one, if we calculate this one, so we're going to have a negative 7. So and so we're going to get the ordered pair of this one. So the ordered pair of this one is equals to negative 2 and 20. This is the ordered pair, and this is the, and also this one we have an ordered pair of 1 and negative 7. So in getting the maxima or the minima, so same condition, if the answer is greater than 0, we have the minimum. If the answer is less than 0, we have the maximum. So let's do the first step in this one. So let's get the second derivative of our functions. So the second derivative of this one, we have a 12x plus 6. So 12 minus 2 plus 6. So we have negative 24 plus 6, so we have negative 18. So it is less than 0, so this one will be the maxima. And if we have f is raised to 1, so 12 1 plus 6 equals 18. So we have a greater than 0, so this is the minimum. So the minimum. So we have the ordered pair of negative 2 comma 20 is the maxima. Then we have the 1 and the negative 7 for the minimum. So our problem number 2 is solved. So in maxima minima, we are not limit in a function problems. We have also the word problems. These are word problems or application problems. So in steps in finding the word problems or application problems. So first, draw a diagram if necessary. So the second step is write an equation representing the quantity to be maximized or minimized. So this quantity will typically be represented in terms of two or more variables. So in the third step, use any relationship between the variables to express the equation obtained in step 2 into a function of a single variable. So differentiate and equate the function to 0 so to get the maxima. So we have a example number 1. So find two non-negative numbers x and y whose sum is 300 and for which x squared and y is a maximum. So this is not a geometric plane number so we don't have to draw it na necessary. So we have a function of x plus y is equals 300, and we have also a second function of x and y, x squared we have a second function of x squared times y equals the maximum. So first we're going to express this one into this one and this one into one single variable equation. So we have this one a so we can express this one in y equals 300 minus x, then we put this one in the we put this one this equation in here, substitute the y, so we have the x squared times 300 minus x in terms of y. So we have distribution 300 x squared minus x cubed equals to function of x. So now we're going to get the first derivative. The first derivative of this one is 600 x minus this one. We have the first derivative. So now we're going to find the critical number, so let's equate to 0. So 600 minus 3x squared equals to 0. As we can see, we can factor this out. So 3x equals 200 minus x equals to 0. So we have a factor of 3x equals 0, so over 3. So we have x equals 0 in the other root for this one. So we have 200 minus x equals 0. So to eliminate this one, we have to plus 200. So we can eliminate. So we have x equals 200. We have a critical number of 0 and 200. So now we're going to use this one 200 to maximize our equation. Now we're going to substitute the 200 into our main equation. So we have x equals to x plus y equals 300, and we have our maximized value. We have 200 plus y equals 300. So we have y equals 100. So we have a ordered pair of 200 and 100. We have x and y. So our two non-negative number x and y. So for x and y is 200 and 100. So we have a second example of the application problem. So a wire is 16 feet long, has to be formed into a rectangle. So what dimension should be a rectangle? Have to maximize the area. So we have to maximize the area of this problem. So we have a 16 feet given. A 16 feet is also called the perimeter of the rectangle. So we have 2 times x plus y. So let be the x and y, the length and the width of the rectangle. So we have the area of x and y. So this one is the maximize. So in terms, so we're going by this one. So we have 8x plus y. Then we get we then we have x equals 8 minus y in terms of this one. So now we have the function of we have the 8 minus y equals y. So we're going to y squared, and the first derivative, of course, don't forget. So we have 8 minus 2y. Then equate into 0. Into y man equals 0 equals 2y. Equals 8, or y equals 4. So we have the critical value number. So let's check if this y equals 4 will be the maximize or the minimum value of the area. So we're going to substitute this one to the first. We're going to get the second derivative, of course. So the second derivative will be -0. negative well of 8 minus 2y equals 0, negative 2. So we have always negative 2. So it means it is the maximized value of the rectangle. So now, and now we have the equation x minus y. So we're going to 8 minus y, or x equals 8 minus 4. So we have x equals 4. So therefore, the area of the rectangle is equals to 4 times 4 equals 16 feet squared. So the dimension of our area or the rectangle is the 4 by 4, or the rectangle or square. So we have a 4 by 4 sides. So that would be all. Thank you.